Good morning, everyone, and welcome to this webinar on Cloud Native Network Detection and Response. My name's Richard Tompkinson from Cloud 10. We've been working in the cloud security arena for over 5 years now. We work across AWS, Azure and GCP. In terms of our customers, we work across public sector and enterprise to help them securely operate in public cloud environments. Now, up until quite recently, one of the shortcomings around threat detection was our inability to extract and analyze in-depth real-time network packet flows. So recent service announcements around traffic mirroring from all the major cloud providers have now made this raw data available. However, what we've been most impressed with recently is ExtraHop's NDR suite of tools. They allow for targeting and in-depth analysis of these flows. So before I hand over to Karam, you'll notice that there's a Q&A button down the bottom of the Zoom screen. If you'd like to put all your questions or comments in this forum, we'll go through those at the very end of the webinar. So without further ado, I'd like to hand over to Karam from ExtraHop. He'll be giving us a detailed overview and demonstration of the product.
Thanks a lot, Richard. Hi guys, good morning. My name is Karam. I've been with ExtraHop for the past 4 years now. Prior to that, I used to work with Cisco and Juniper Networks. So I've got a wealth of experience, almost 20 plus years in the networking industry as well as network security industry. ExtraHop comes from NPMD as a background, so which is Network Performance Monitoring and Diagnostics, which basically means that we've got layer 7 analytics as a visibility, underlying fabric of that. We took that visibility and specifically target the security use cases for the customers now, because we've got application analytics layer available to us at speeds of the networks, cloud native as well as hybrid. We can surface behavior as well as security anomalies, which are very, very relevant to the customers in real time. That's what my background has been. In this webinar, I'm basically going to talk about some of the existing data sources that the customers have with telemetry. Now, that telemetry is very, very key to the customers from a data source perspective, because without that telemetry, their monitoring and security fabric, both of those things are broken. So let's look at an application delivery chain, which is where the critical assets of the customers reside. Think about these critical assets as your web servers, where you offer services or payments portals across to the customers. Those payment portals nowadays with COVID area, as you can imagine, online shopping is one of the key things, and online deliveries is happening all the time. So people go, and the transformation from the businesses has been towards these electronic portals. So what happens with that? Think about your web service that you go ahead and offer. If that is part of an application delivery chain, that basically means that it has to work in conjunction with a lot of additional layers, which could be residing anywhere. So think about, www.cloud10.com.au is a website, right? So because this is a web service that they offer, if somebody goes into that HTTPS as a request from a user perspective, now this tier by itself could reside anywhere. So which basically means it could be cloud native. It could be an EC2 instance. It could be a PaaS service. It, for example, could be a completely SaaS service or on-prem, right? Residing on a VM or something. Now for it to give a response back, the first thing is it has to receive a HTTPS encrypted request from a user. That user could be anywhere. So what happens is, first of all, that enters the realm of a cloud native provider or a hosted service on-prem that comes in via a firewall, some sort of a firewall which is present somewhere, right? Or via the NAT gateways or something. Then that request needs to be decrypted and load balanced. Load balancers, think of them as application layer load balancers. Think about on-prem stuff like Citrix as well as F5. Think about Amazon-based network load balancers and GCP-based network load balancers. That's where the request is eventually load balanced across to a specific web server. Now, out of those EC2 instances, or for example, VMs, whichever is presenting that, it needs to work in conjunction with a lot of additional layers. Now, what those layers would be, could be a middle tier, could be, for example, an application layer, could be another DNS lookup so that it can go ahead and request some data from a database, like a catalog, like student information, like customer SAP systems, like CRMs, like ERPs or anything. And then maybe to fulfill that request, it has to go to storage tier, but it needs to do a DNS lookup first. All of those things work together with each other to give a response back across to a user. But all of this is the east-west corridor. Okay, so the perimeter is gone. So the first request which came through the firewall, that's it. Now, all of these tiers, once a bad actor or a legit user is in that application delivery chain or the east-west corridor, there is not necessarily any firewall functions available, okay? Or layer 7 inspection is not necessarily happening. So if somehow this perimeter gets breached, they're inside the perimeter. So they can pivot from one device to another one. Why is that important? That is important because these services could be anywhere, first of all. What does that mean? That basically means that, you could have a Route 53 as a DNS server in AWS. You could have, for example, a Lambda function. You could have a PaaS service. All of these application delivery components could be a manifestation of any of the services, which could be a combination of things, right? Active Directory if, users are trying to access their own applications. Probably it's SAML-based authentication, which would maybe fetch some identity information from some identity stores. Think if you're a hybrid play, you would have tons of sensors available. Those sensors and all of these individual components, the first thing that they have to do is that they have to provide some sort of analytics to you. What is that analytic that we have been used to for the past 20 plus years? That is log. Okay, so you go ahead and write a log entry into your firewall or a proxy box, or for example, a load balancer log or web server log or application server log or something, right? Now, that's one of the key data sources that people have been used to. For example, in AWS terms, that potentially could be called a VPC flow log if all of these components reside within a VPC, right? And then individually on every single application tier, you would have to write their logs to be sent out to some sort of a console so that you can gather all of that login information. So the first thing that you would have to look into, okay, if log is my data source, are there any gaps associated with them? Can I realistically log every single one of these components in my application delivery chain? That's one of the key things. So are there any gaps associated with them? The second telemetry source could be your agents. Now, from a security perspective, these things are called EDRs, which is endpoint detection or response agents, or next-gen firewall or AV, agents. Think about CrowdStrike, think about Carbon Black, think about Cylance, think about Sophos. All of these things eventually get deployed on the endpoints from a corporate user perspective, right? They're enterprise assets. Sometimes these agents, both for performance as well as security, can also reside on these server-side critical asset components as well. Now, the thing about these agents as well as the logs are that you can't necessarily deploy them everywhere, okay? So you lack the visibility from every single tier of the application delivery chain. That's one of the key things about both of these data sources. Let's delve a bit more into those data sources because understanding your visibility gaps is paramount to your security strategy. So now, what are some of the limitations that we've got with agents or EDRs or next-gen AVs, or what are the gaps with logs and SIMs, right? And what is the third emerging data source for your SOC? Couple of things that you have to notice, with agents, they're not necessarily applicable to cloud native services. So as an example, you can't instrument an RDS. You can't instrument, for example, an S3 bucket from AWS, or you can't deploy them on application load balancers or on Lambda services or something like that, right? You can't deploy them on there. So what does that mean? That means if you can only install this on an IaaS component, what about the other application delivery chain components, which you can't instrument with these things? So that obviously is a gap for you guys, right? Then it depends, how can you scale and deploy them across the full hybrid enterprise? You could be pure cloud native. You could be born in the cloud in the past 3 years. Any of the companies in the past 3 to 4 years are purely cloud native. Well, again, you've got some limitations in there. But what if you're hybrid? You've got some, on-premise instances of the applications which you're migrating across to the cloud. So can you realistically deploy these performance agents or security agents on every single endpoint? They obviously consume system overhead because they're going to be chucking away at the CPU cycles of that individual component. Think about, for example, an Oracle database or MS SQL database instance that you've got. Could be an IaaS EC2 instance, right? Via RDS, you're basically using MariaDB or some of these components. If you are from a database perspective, the database administrators absolutely don't want anything which chews away CPU cycles away from its actual database function. If that is the case, what do you do? And that's an overhead. Some of the other live examples that we get to see in every single customer base, SAP is one of the key applications that people have. on-prem and now migrating across to the cloud. What happens with SAP if there's a problem? The first thing, if you log a ticket with their TAC or support team, they would say uninstall or undeploy any of the agents, EDR components, or anything that you've got on the box. Otherwise, we're not going to touch that SAP install. If that is the case, and you're obviously from a security standpoint, you're a SOC resource, what do? Where's your security strategy gone? Because now there's a gap. You don't have any visibility because you relied on the agents and all of these things, right? So what happens then? Some of the gaps and challenges that we've got, SIM or log as telemetry, both of these things, they can be tampered with. So you can, for example, rewrite a log. Now, nowadays that's easier as compared to previous days. They're also self-reported. And what is the metric set that these logs have? You have to do the correlation. You have to send everything out. Logs consume space and time and everything. And what are the dimensions? Think if you've got Microsoft IIS as a web server or an EC2 instance that you've spun up, your log would be way better as compared to my log. Yeah, because although it's the same instance, it might be the same version of IIS that we're running, but how you write your log would be completely different as compared to how I write my log. I might not capture the relevant fields, but you do. So the key nature or the key fundamental of log is that it's self-reported. And then it's costly data and storage, right? Think about, for example, any of the SIM providers, they've got a storage tags. You have to, sort your Splunk or Splunk Cloud or some of those vendors' solutions for them so that you can aggregate all of those logs. First of all, store, then index them, then allow the searching capability, then create those regex expressions and everything to go ahead and get filtered on the data. But one of the key things is if the data from a login perspective that you're getting is not accurate or it's tampered with, or if it's deleted, what do? Your visibility from both of these realms is gone. The third emerging source of the data, hence, is something which is called network wire data, or Gartner is calling it NDR. NDR is network detection and response, which basically means all the clients and servers go ahead and transact over a network. In on-prem world, that's easy. You think about your critical assets, which are in the data centers, right? So think about Cisco ACI as a fabric, or Arista spine leaf architectures, or Juniper QFX architectures and everything, right? So that network, you can tap into that network. Now, with VMs is obviously easy as well, right? So you've got V switches or VDSs, which can give you promiscuous mode or ER-span-based traffic tapping. But in the cloud world, recently with AWS as well as Azure and GCP, they've identified a pure visibility gap, and they knew logs is not going to cut it. Hence, they've allowed that capability natively in the cloud where traffic passively can be mirrored across to collector tools like ExtraHop. But that traffic is from the network. So which basically means, first of all, that works at the network speed. It is very comprehensive data set. It is real time. You don't have to instrument any of the endpoint agents or workloads via logs or agents, nothing. It is observational data. So tools like ExtraHop, we keep on monitoring the network 24/7 for anything and everything. And based on that comprehensive set of data, we can surface anomalies in real time. It's empirical and definitive. This is what it is. You can't tamper with the network. Versus you can tamper with these things. You can undeploy these guys. You can, drop a table, which is like deleting a log. If you delete a log, you obfuscate a log, your telemetry source is gone. You can't tamper with the network in that shape. And you've got a very rich and complete context. That's why the emerging data source for the SOC is network wire data, which is a superset of both logs as well as agents. And in the subsequent slides, I'll go over some of the examples with a comprehensive demo towards the end. This is how the architecture of ExtraHop works. So ExtraHop in an NDR play, we've got something of an offering which is called Reveal X. So what does that do and how does it work? Think about your cloud native components. Cloud native, AWS, obviously multi-cloud providers like Azure as well as GCP. What they have now given the ability to cloud native customers is something which is generally called a VTAP, a virtual tap. So which means AWS has got something which is called VPC traffic mirror. Okay, Azure's got something which is in beta still, which is called VNTAP, virtual network tap. GCP's got something which is called packet mirror, So basically, they can replicate the packets in real time from any of the interesting workloads that the customer wants visibility into. That capability obviously is available for hybrid customers who've got their on-prem data centers or virtualized data centers as well as branches. The typical scenario that we've got at these levels is something which is called span techniques, or for example, ER span, which is encapsulated remote span that you can remotely send from a branch all the way to a data center or to a cloud or something, which is over IP hops. Or you've got providers like Gigamons and Ixias and Big Switches acquired by Arista, which is optical taps and copper taps that you physically deploy on the cables, which basically bends the light. And you've got an actual stream of packets. So first thing about RevealX NDR from ExtraHop is that is passive. It's not going to sit in line to the traffic store. What does that mean? That basically means that if there's latency, if there's any requirement from a traffic flow perspective, we're not going to add to it. We're not going to be sitting in the path of the traffic, which means we would sit on the side in the corner, observing that traffic 24/7 and giving you the analytics in real time from that mirrored copy of the traffic. So it's real time, no agents required, no logs, nothing at all. But because this data set is so comprehensive, what we do with that data set in real time, so think on-prem, it could scale from 1 gigabit per second all the way up to network speeds of 100 gigabit per second, the analysis at layer 7. Or in the cloud with AWS, for example, it can go up to 25 gigabit per second worth of traffic. What we do with that traffic in real time is that we do our F5 pedigree allows us to do full stream transaction analysis on that. What does that mean? That basically means that we reconstruct the TCP stack of every client and server in real time, in memory, in RAM, that is, right? That allows us to run 70 plus protocol sieves on top of that data, okay? From the actual packets, not logs, actual packets. So our data set is very comprehensive. So then we know it's a DNS transaction versus it's an MS SQL transaction versus it's a CIFS transaction, right? So we know at a transaction level, recreation of these protocol stacks of what it is. What are the devices talking on the wire? Is that an EC2 instance? What is the tag associated with it? What are the usernames surfaced in those protocols? If that is CIFS, there's a different username. If that is Telnet, for worse or whatever, that would be a different username altogether. Are there applications? What applications are they? What is the mapping of the application delivery chain? This application transaction came from a web down to a middleware tier, down to, for example, a database, down to a DNS, down to a CIFS share or something. So we can map everything out of the box from that real-time traffic. And then what we do is we run on this comprehensive data set, machine learning, which is hosted in the cloud for customers in Australia, in Sydney. So what happens with that is, why do we need cloud scale machine learning? Is basically so that we can give you high fidelity alerting or detections in real time. Think about a breach which happened in US almost, I think, 4 years ago, which was Target. So we've got, our execs who came over to us and joined from FireEye. So they gave us some details around that, which basically was around the fact that FireEye was already in place at that customer. And there was an alert which was raised at that point in time. But because of the phenomenon that we call alert cannon, which is you get thousands and thousands of alerts every day in a socket engineer's shift, right? There was no way to prioritize those alerts. So the analysts during that shift, although the alert was raised, they could not pay attention to it. And hence it was breached eventually, right? So machine learning based in the cloud, first of all, allows us to look into all of these different vectors and dimensions of a very comprehensive data set and run machine learning models. Then the outcome of that is that it surfaces the anomalies in real time based on behaviors, based on CTI, so threat intel, as well as signatures. So combination of those things is surfaced to the customers right away with alert priorities so that you can pay attention to the right things at the right time. And then what we can also do is ingestion from the network is what we do, but then we can orchestrate based on this telemetry information, we can orchestrate actions. So that orchestration of the actions in, for example, AWS world would be executing an AWS quarantine function. I want to take that EC2 instance literally within milliseconds to a quarantine state. by executing, for example, some Lambda functions, or writing it out to an SNS topic or something, right? We could do all of that based on the detections that we've identified from the real-time telemetry. Yeah. Or we could send, for example, if Splunk or something is your go-to place for any of the investigation framework, then we can pipe everything out via syslog as an interface across to Splunk or IBM QRadars or anybody who can consume syslog. RESTful API for invoking an action bidirectional. Yeah. Or Apache Kafka if you're building a data lake, or for example, MongoDB, or even the customers who don't have any of those supported interfaces, we can send something out via a raw UDP or TCP socket. So the platform is very, very intelligent because it's got layer 2 to layer 7 dimensions or vectors of that data that they can understand in real time. Then it can integrate with anything upstream to pipe that relevant metric out. That's how the architecture works. And it's very simple for customers to consume because it is agentless. All they need to do is just look into one single browser tab for everything. Cool. A quick comparison, because this session is more about cloud customers who are born in the cloud or who've got some sort of a hybrid play. Think about VPC flow logs, which is pretty much every single customer's go-to place in terms of visibility from AWS workloads. Think about a VPC. Within that VPC, you obviously have got VPC flow logs. So VPC flow logs are like flow records, or think about on-prem stuff like NetFlow. So they've got tuples in there, right? So, this is a generic example of a VPC flow log. So what does it do? It allows you to capture information about the IP traffic going to and from network sources in your VPC without the need of an agent. So obviously AWS also wants customers to have frictionless visibility, which is without installing any of the agents at all. So how can you do that? You can generate the logs from within the VPCs, from within the subnets. Here's an example. What is the version of that VPC flow log? What is the VPC ID? What is the subnet ID? What are you getting as part of the instance? What is the source address? This is something that we're very, very accustomed to in on-prem environments, right? Source address, destination address, what is the source port at a TCP level or UDP level? What is the destination port? What is the protocol type? So this is like TCP, right? And what is the type of that information? So this IP information is IPv4 and not IPv6. Now think, this is what is written from an AWS VPC flow log. Is it comprehensive? It is, but I'll show you some additional comprehensive dataset natures, right? This is just at one end. If you want to get visibility across the application delivery chains, you have to enable login at every single one of those components. This doesn't tell you anything about database. This doesn't tell you anything about your S3 buckets, as an example. This doesn't tell you anything that you've orchestrated on an IIS. Okay, there's no web component in it. There's no CIFS transactions. There's no DNS information. It's only a source IP, destination IP, maybe network bytes in, bytes out sort of a flow, right? So yes, it's a good information to have, but look, if the network could provide you with more comprehensive data set, how would it do that? That's something of a feature which is called AWS VPC traffic mirroring. What does that basically mean? That basically means from a VPC, you could set up policies. What are those policies? They're called traffic mirror sessions. You configure a traffic mirror session, the traffic which is coming inbound and going out from a VPC, you could pipe that traffic from their elastic network interfaces via invoking a VPC traffic mirror native function within AWS, and similar for the other cloud providers like GCP as well as Azure. So now that traffic layer 2 and above, not the log, not the agent-based information, the traffic itself, the packets are mirrored across to collectors, one, us, or multiple collectors, whoever can consume that information. Now, how does that look like? Now, it's good that natively in the cloud, we don't have to install any taps or anything because you can't basically tap, right? So you can traffic mirror natively within the cloud now. Now, how good is that? What is the use case of that information? And here's one example of that. Think about layer 2 to layer 4 analysis of a database transaction. Think about VPC flow log. What is that going to tell us? That's going to tell us that, okay, there was unusual amount of SQL traffic between a database and a rare client. How does it identify that? Most probably on TCP, and the protocol would be 1433 if that is MS SQL. Okay, and what it's going to tell us? Oh, there was unusual volume of data transfer. Network bytes in, bytes out was quite a lot. Versus what ExtraHop can tell you. Look at all of these phases, right? So it starts from the protocol fluency that we've got. It starts from the fact that we understand what a database transaction is, because we can recreate the TCP session of the client and the server from the network. Now we know that a client with a source IP blah, with a source hostname something, it tried at a specific millisecond level timestamp to log into a database server with an IP address that with a server name blah, and now it failed. It didn't have the right credentials. So we can see that. Why at a database level? Because we can recreate the stack. Then we now know at some point in time beyond this, he was successfully able to log into the database instance. Then he did some select executes. So select is like a statement where you read something from a database. Now think from the network without writing anything into MS SQL or VPC flow logs, you can get literally millisecond level timestamps right away. Who the user was at a database level. You know, what was the database instance that he did a select statement read from? What was the method? How many bytes were returned? Then after reading all of that data, if that was a bad guy, he dropped the table, which is basically dropping or deleting the information. He's wiping his footprint off. Yeah, and the database responds in the affirmative. And then the client initiates exfiltration of that information, which was visible as network bytes in, bytes out. So look at all of these tiers of information, which is left from a visibility from layer 2 to layer 4 perspective. That's what wide data or the network telemetry can bring you towards, because all of this information then is baseline with an extra hop. And then we surface the anomalies that this is not the right behavior. Root should never be able to log into a database instance. Signature plus behavior plus CTI information combined surfaces the anomalies. Cool. And then finally, how does ExtraHop stitch it all together from an architecture perspective? We give the customers hybrid visibility. So customers who are cloud native, you know, all three of these vendors, we've got AMIs or VMs that you can deploy literally within those instances, or you can deploy a sensor on premises in the data center, in the remote sites, IoT visibility, whatever. Those sensors basically capture the packets in real time from those source locations and run ML in the cloud on top, as well as the control plane can be in the cloud, which is where they talk to the sensors restfully and fetch all of those metrics. And then, you know, what are those metrics? There are 5,000 metrics across 70 plus protocols. We can even, because of our F5 pedigree, we can even decrypt TLS 1.3 PFS, as well as obviously the RSA algorithms, because the bad actors are now consuming all of these encrypted channels. Think about tools like Empire. You know, they go ahead and breach the perimeter. Then, you know, east-west corridor, they go ahead and establish TLS sessions with each other so that they can hide the commands that they're executing from the source or the victim to the offender or the offender to the victim. Yeah. And we can do this at scale at 100 gigabits per second, natively in the cloud, physically, virtual environments, all of them we can tap. What does that give you? This is the analytics that we're doing from the truth of the data source, which is not logs, which is not agents, it is the network. The network doesn't lie. You know, back in the day, we used to have, you know, something which is called packets don't lie, which is basically the same thing. But you don't have to store the packets. We run the analysis in memory in real time from it and give you the analytics, okay? So unified security across on-premises, anywhere, multi-cloud environments, 360-degree visibility. So situational awareness of every single dimension of the transactions that you're conducting without friction. That is key. No agents, yeah, no logs. You don't have to, you know, deploy some logs somewhere and ensure that the log sanctity is there. You don't have to do that. The SOC guys just have to execute a VPC traffic mirror, and that's pretty much it. And it can also be delivered purely from the cloud. For AWS sensors, we just give them a pure SaaS service. And it can be a hybrid combination. Sensors could be anywhere. Yeah, you could tap your multiple cloud providers for the visibility, and we can give you a hybrid service as well. Now what I'll do is I'll go ahead and pivot into a demonstration. These are some of my contacts. So this is myself, this is Glenn Maloney and Sachin Sohani. These are the RSMs that I go ahead and work with across Australia and New Zealand. So please feel free to reach out to them. But I'll quickly pivot into the demo and answer any of the questions that you've got in the Q&A panel. And please, you know, reach out to us in the Q&A panel for any of the questions that you might have. Here's a quick workflow. As you can imagine, so this is www.extrahub.com/demo. You've got access to this demo as well. There's a 6-hour PCAP that we're replaying in the environment so that you can see how the workflow is. If you're a SOC engineer, what's going to happen is you would come into this ExtraHub console. Now, this console could be presented again anywhere, in the cloud natively or on-prem, anywhere. The SOC engineer would say, okay, tell me what happened in the past 6 hours. Or I'm a SOC manager. I want to see what happened in the environment in the past 1 day. Or there was a specific time, 5th of August, maybe at 1 o'clock in the morning, there was some bad activity. So I need to roll back into that environment and see exactly what happened. So I can pick and choose. This metadata resides on the box, okay? This metadata, the comprehensive data set, is extracted from the wire. So I say, for example, show me ExtraHub in the past 6 hours, what happened in the environment? I can now see the east-west corridor, okay? The perimeter is post-compromise. We're living in a post-compromise world. So now we're seeing, think about, this NDR as maybe synonymous with next generation IDS in the east-west corridor. IDSs used to sit at the perimeter. This is east-west. So the IDS has got now next-gen IDS, ExtraHub, NDR. It's got pervasive visibility across all of the components of application delivery chain. So it can stitch them together. Now it's telling you in the past 6 hours, there's 38 security detections. And those security detections, some of them are C2, some are reconnaissance, some are exploitation. Somebody is doing lateral movement. So pivoting from one asset, maybe a database, across to a SIF store or something, yeah, in the east-west corridor. Or somebody's exfiltrating some of the information. So you can click on any of these things and start filtering and zooming into them for an investigation perspective. Or if this is really high fidelity based on the investigation that you provided, you can invoke a quarantine function right away, okay, to filter that host who is doing bad stuff. Okay, you could do that right away. Another view into that security tab, you've got critical assets with the detections now. Do you pay attention to maybe some of the BYOD sort of an asset on an on-prem environment? Or for example, there's a file server. Yeah, do you want to pay attention to that in terms of priority? Or do you care about your EC2 workloads, which are manifesting, for example, or presenting themselves as web servers? We identify the behavior of every single workload because we've got very comprehensive layer 7 visibility. You don't have to tell us anything. We will auto-discover and auto-classify your environment. So then you can pivot into the detections with a web server, because if that is compromised, that is bad. Or you can prioritize the alerts or your investigation based on the alert risk score. So that means from 0 to 99, do I care about maybe a ping scan? Or maybe I want to pay attention to ransomware activity or something. Yeah. Or for example, data exfiltration going on. These are the high fidelity alerts. The alert cannon example that I gave from Target from US breach. This is how the SOC analyst can go ahead and prioritize things. Okay. Now let's look at the network perimeter. Let's look at the network metrics from health indicators perspective of what are some of the key metrics that your SOC analyst should look into. Why is your HTTP tier at an aggregate level showing that there are so many thousands, 284,500 server errors? Why is that happening? You can pivot into that right away. Why are there self-signed sessions? They should not be there. Why are there insecure TLS-v 1.0 protocols? I can tell you so many times that I've seen SL certs, which even go back to 1998 in customers' environments. So obviously, TLS was not even there. It was SSL v2. So think from a bad actor's perspective, how easy it is to compromise SSL v2, yeah? Or deprecated ciphers like RC2 or RC4s, right? Or DES. So those sorts of things, visibility right away. How many those deprecated cipher sessions do I have in the environment right now? Which is the client, which is the server? I can pivot into those things right away. As an example, who is throwing 404 errors to me right now? Click on that. It gives you the relevant metadata right away. That's Favicon hosted on 249.204, which responded 48 times by 404. So as you can imagine, that's, for example, an EC2 instance, which is hosting in Microsoft IIS. And, that's the homepage of that. And favicon.ico file should be there, but it's not there. So clients are trying to access that file, but they're unable to. Cool. So you can pivot into those things right away with one single click, because this is all of that metadata that we keep on extracting 24/7. Here's the view. What are the new EC2 instances that somebody spun up? And they did not tell me, the security team. Generally, security guys are the last ones to know what the DevOps guys did. DevOps guys generally don't tell them that this is something that we're executing. Or even if that active EC2 instance is doing something bad. There's a broken library within that, and it's reaching out to, for example, a Chromecast library or something. How do you know? The logs aren't going to tell you. That broken library is not going to tell you itself, but the network would, because these transactions are happening on the network. Yeah. Then this is something which is called activity maps, layer 4 to layer 7 activity maps right now, parsed for you. What is the database IP address? Who is he talking across to? Is that a database conversation? Should he have that conversation? Yeah. Forget DB, show me some other types of activity. CIFS. What is my CIFS layer 4 to layer 7 activity like? Here's a web server or workstation who's behaving as a web client. He's talking CIFS across to a file server. What are those transactions? I want to drill down into that side, or I want to drill down into the other side of the conversation, or I actually want to see what those transactions are. The workflows are very, very quick. Metadata is already there, and the comprehensive data set again from the network. So you can just go into the records and see exactly what they're saying at that layer 7 transaction level. Yeah. Another view is perimeter. Show me, for example, what is my cloud service consumption? Generally, people hybrid, they don't have a clue of who's talking across to Amazon S3 buckets, or who's reaching out to Apple, or how much transactions are going to Azure cloud. What is the tenancy of these Amazon workloads? Is that hosted in China, or is that hosted in, for example, EMEA or US? Where is my data going? Nobody's got a clue. With one single click, you can click on these things and get to know what are the internal assets. As an example, on an Amazon S3 bucket, what are the internal IP addresses which are sending so many bytes out? At what point in time they send those things out? Right here. Click on that. The timestamp is right there. 5:50 a.m. in the morning, he exchanged so many bytes out with Amazon S3 bucket. Now you know your internal IP. You can quarantine it. What is the cloud service breakdown? Tell me that. Who's talking to who? Why are people going, for example, to Cloudflare or Gmail, or who's that guy? What is the cloud service consumption? Right away from the network, it's going to be shown to you. As you can imagine, for example, Gmail is all SaaS. Outlook 365 is all SaaS. You can't necessarily instrument them unless you do, for example, some API calls or whatever, right? But you're going to be dependent on their telemetry. This is network feeding all the telemetry, which is in real time for you. Empirical, definitive, SLAs, everything. Yeah. Now think about the perimeter again. Think about large data volume uploads. Your internal assets, why are they talking to somebody who's on a CTI feed? That looks like a suspicious public IP endpoint. Why suspicious? Because we've got CTI data embedded into it. So threat intel. This guy, public IP or URI, for example, or a domain is on a threat feed. It's on a malware watch list. So now we give the SOC analyst very comprehensive investigative capabilities so that you can see what's going on. Yeah. Uncommon destinations. Somebody from the internet is reaching out to an internal IP address, which looks like a web server. So if that's a web server, ring the bells right away, because that's a critical asset. Now you want to see exactly what's going on. You want to investigate. And here's the timestamp of those CTI-based infections happening, right? So what are you going to do now? You're going to start drilling down into that device. You're going to say, ExtraHop, tell me everything that you know about that web server. This could be an EC2 instance. Yeah, it could be anything, cloud native service or VM or on-prem workload, bare metal workload, right? What's the MAC address of that? What is the IP address of that? Via API integration into AWS, now we can even tell you what are the VPC, subnet IDs, instance IDs, everything that it belongs to. What are the tags associated with that EC2 instance as an example? Yeah, that information would be visible to you right here. Now, what is the behavior of that guy? That primarily is behaving as a web server. That's why we classify that heavily as a web server. But because we can layer 7 parse, this guy is also a destination for NFS. So it obviously has got some network file shares on it that it's serving across to the clients. He's talking to peer IP addresses. One of them is in Russia. Is he sanctioned to go ahead and do that? Is he allowed to do it? Is it in your DMZ? Is that an internal IP address? Yeah, that is an internal IP address. It should not go ahead and talk to public IP addresses, right? But it is. Show me, for example, what is the visual map of that? This guy is the web server. Now he's talking across to a database instance. What does that mean from a bad actor's perspective? That means that if I compromise this guy, I can potentially go ahead and pivot into this guy and steal all the student information or the customer information from a CRM store or something. Yeah, I can do all of them, and then wipe my footprint off. Tell, the SIM tools that I did not even go here. So visualizing the attack surface and functionally then pivoting into those things. Tell me, what does that guy go to that device, and start mapping every single layer. Yeah. Or look into the detections. What detections ExtraHop have I thrown across to you? This looks like, for example, in the past 6 hours, some Drupal exploit. Okay, let me see, what is that Drupal exploit? Let me start from a stock analyst perspective, pivoting into those detections. Why? Because this is, again, a prioritized alert. So I'm not looking at a ping scan. I'm paying attention to highly prioritized detection that I've got. So that ExtraHop is classified as exploitation. Okay, so think about the phases in a cyber kill chain of Lockheed Martin. Yeah, that's exploitation phase. Why have we picked it up? We've picked it up because this server reached out. So the offender was this public IP for whom you can do this errand lookup to see where it's residing, the geolocation of that guy. The admins who are looking into that host, he's reaching out to an internal asset, and he used a HTTP URI of this. Obviously, this would be available to you if you decrypt SSL. Yeah, because the transactions would be HTTPS. So you're decrypting. You have the ability to go ahead and decrypt. If you can't, you won't be able to see this URI. And you won't be able to see this post command. Yeah. Here's the payload part that we picked off from that HTTP payload, first by decrypting SSL, then by looking into the payload and picking up the snippets of infectious payload. Why infectious? Because this guy is running a Drupal 7.x CMS, and that is exposed. So there are a bunch of CVEs which are available out there for customers, so for bad actors to go and exploit. So we've picked that up because we can see that those snippets from the payload. Now, what are your investigation steps? So first of all, let's look into this side, right? So right away, we map these detections to something which is called MITRE ATT&CK framework. So now we know what is the TTP associated with it. What is the risk factor? Why do we think it's 83? Because the business impact to this exploit could be huge. We level up the analyst. What is this vulnerability doing? Without Googling into any of those things, you can see that data present in here. Attack background. How does this work? How does this visually look like? What are your mitigation options? SOC level 1 analyst can go back to that application owner because he knows that guy. This is that guy right here with the IP address blah. He can go back to that guy and say, you're running Drupal 7.x. Go ahead and upgrade Drupal framework to blah because we're getting infections from him. Yeah. What is additional references, CVEs that reference this, OWASP platform, right? What are the references for that? And then the really cool thing, attack campaign. Attack campaign is where we go ahead and stitch all of these independent anomalies together to identify whether it's just a one-off detection that we picked up, or is that part of a real attack campaign? Was he an offender? Was he a victim at this point in time? What can you do? Okay, even if I picked up, yes, this is bad stuff, I can go ahead and get the packets, optionally the packets, which are the forensics key for the security guys with a workflow. I didn't have to have petabytes of packet store to be able to sift and sort and get to this outcome. We gave you that outcome first of what's happening. Then if you optionally want the packets, surgically, we can give them to you. But then you can also look into all of the activities. So what happened T+15? Let's click on that. Show me, what is that anomaly? There's a different risk score for that. But you can imagine we're tying all of these things together, which is really, really cool. Yeah, because the analyst wants to understand if this is just independent detection or part of a larger attack campaign. What's he doing? He sent an unusually high number of DNS reverse pointer lookups. Why? Because we now have baselined the behavior of this guy in your environment. Cloud natively. We now know this asset, how many reverse pointer lookups does he do? Yeah. So we know that he never does it. This is a critical asset. He should not do a reverse pointer lookup. This web server should say, okay, give me the IP address of www.somethinginternal.database.com. And the DNS should respond with that IP. He's saying, here's an IP, give me the host name. So that's anomalous to this guy. So we picked up a behavior-based anomaly in here. And then how can I investigate? These are the host names that it's querying for. Yeah, he's looking for these things. What are the packets? Give me those packets. What are the TTPs? What are the visuals for these? Everything available to you. What did he then start doing? He started doing TCP SYN scan. So he's looking for pivoting into the assets which are open, which have got TCP ports open. What are the scanned IP addresses for which he's looking at, look at these, unestablished SYNs out. So he most probably is enumerating the ports of open IP addresses. What subnet? He's looking into 192.168.221. Everything right there. Give me the packets for all of those things. But from the metadata, it's telling you exactly what's going on. Now that he's infected somebody, he's looking into PowerShell executes. So these are the PowerShell commands that this guy's executing after pivoting into them. So now you can see the payload that the attacker is using to go ahead and enumerate something. Yeah, all of those things. What was the service name that he used for them? Give me the packets, give me the TTPs, all of these things available at your fingertips. Then he started doing, for example, T plus whatever minutes, some SMB brute force to read some files from, for example, a physician's computer or something. What login usernames that he used at a CIFS level. Those sorts of things are available to you right there. And then you can make a decision of why should I quarantine the endpoint or not? Should I just log this? Should I deny it? What should I do? So these detections are high fidelity, but understand how are we surfacing these detections for you? We first of all have to understand what is the underlying layer 7 protocol classification. Understanding your environment completely. What are the MAC addresses, the IP addresses? When did this asset started talking on the wire? IoT asset, third-party device service, talking back to my EC2 instance. What is that device doing? He's a critical service. Yeah, he's a web server. He's a database server. So you should pay attention to these things. What are the protocols being consumed in my, cloud environment? Do I have database? Am I using MariaDB? Am I using Microsoft SQL? Show me those database commands. What are these errors? What are the usernames being used in those database responses and database errors? Who are the clients? Map out your complete environment. Based on this rich set of telemetry, only then we can surface the anomalies for you. And imagine, this is completely frictionless. We did not ask you to install or send us the logs from MariaDB or, for example, your MS SQL EC2 instance or anything like that. We did not ask you to do that. We just said, set up a VPC traffic mirror, and that's it. No agents, nothing at all. And you've seen how comprehensive we can get. A quick example would be, understand, for example, if there's any clear text protocols in your cloud environments. I've seen them all the time. Queries, clear text select statements going out to SaaS services even. How do you audit that stuff? Broken libraries, the DevOps guy basically built something malicious of a backdoor. Or that library that he's referenced in his code, that is reaching out to, for example, a bad IP. It's opening backdoors for you guys. How do you know that? The network's going to tell you that. For example, understand your SSL environment without even decrypting it. Show me, for example, what are, for example, the TLS or SSL v3 or v2 versions that you guys are using. Why are you using deprecated ciphers? As an example, do you have RC4? That is bad. Understand the footprint that you've got from an SSL perspective. Certs which have expired, only this one single use case is gold for customers. They don't even know the EC2 instances they've got, the SL certs that they're running on top, when are they supposed to expire? Think about if that is, a web service which allows payment transactions to flow through them. If that has got an expired cert, the service is going to get broken. Yeah, so those sorts of things at the fingertips. Understand who are the servers, what are the clients, what are the host SNIs, what are the certs, so that you can map out completely your environment and then take some actions from there. And obviously, this is also applicable to the customers who are hybrid, understanding their footprint, for example, from an on-prem perspective. IoT devices, this is a glaring example of them. We pick up the model numbers, your Cisco devices, your Polycom devices, your Avaya telecom boxes or something like them. The cameras, what are their models passively? Those sorts of things we can pick up right away. And then understanding their behavior so that we can surface the anomalies for you. Why is this camera establishing SSH connections outbound? Should he even do that? Why is this camera reaching out to an IP in Russia or China? I've seen so many examples recently these cameras like Swan cameras and everything, or high T cameras, they reach out to AWS services in China all the time. And they keep on hopping. Their boot sequence is coming in from those services. So how do you know, if that is compromised, malicious information being transacted across the cameras? They do this all the time. But how do you know? You can't instrument that camera, but you can see the network, and the network tells you what the behavior of these devices are. And that's the only way to go ahead and see that. Unconventional protocol communication. Why did we flag this to you? Look at the metric. He's doing, this is the offender, and here's the victim. This is your camera, and this is a public IP. He's transacting on TCP port 8888. How many bytes? 87 kilobytes. That's nothing for a camera. If at perimeter you had to set up a policy, for a camera, you would say the threshold should be 1 megabyte or something, right? This is 87 kilobyte. You would never get flagged for this. This would be very noisy if you keep on setting the alerts for this, right? But behavior-based anomaly, we're basically saying that this camera in your environment is distinctly behaving as compared to the other similar cameras. This is called peer group anomaly from an ML perspective. So that's why we flagged it to you. And then we're stitching everything in an attack campaign to you. These are the MITRE ATT&CK references. Even MITRE ATT&CK, there's a very, very cool thing that we came up with. That is something which is called the MITRE ATT&CK visualizer or navigator. Your compliance, the phases that you've got in MITRE ATT&CK, from that phase, tell me what are the TTPs which are active in my environment, so that I can go ahead and look into those specific TTPs. There's a brute force happening. What is that brute force? There's a spike in asset session. So you can pivot into those anomalies right there, even by visually looking at the techniques that MITRE ATT&CK gives out to you. Yeah. So very, very comprehensive platform. But I think the takeaway that I would want you to have from this is that extra hop, maybe look into this. This thing right here. Don't have to deploy any agents anywhere. Cloud natively, we can now see the packets, which are very, very comprehensive. And the metrics that we can extract in real time is what gives us all of the insights, which we can then use to surface live detections for you. Okay. And we've got historic metadata on the box. So you can go back in time and see exactly how that device behaved. Nowadays, some of the NDR vendors, they're just detection frameworks, So for example, there's an alert, and based on an alert, they can start doing something. But they can't go back in time and show you the exact baseline from that protocol perspective or that device's perspective. Example would be right here. This is the devices that I've got. So let's look at this life-size camera, right? So that life-size camera, I'm looking at the baseline for that guy from a traffic perspective. Layer 7 stuff, I can go back in time, not 6 hours, go back to past 1 week. And obviously, because this is cyclically playing the PCAP, you can see that behavior. So that's the PCAP that we've got, right? But you can go back in time and see exactly what that guy did at that point in time. What is the SIP aspect of it? What was the SSH sessions that the guy established? Which clients or servers was he talking across to? What cipher suite? All of these baselines are not going to be available with any other NDR player. This is where extra hop comes to you from the layer 7 fluency of NPMD background. That is really crucial to understanding what the network layer of that device tells me. What is the TCP layer of that device tells me, yeah? And then you can look at all of those metrics and put everything into play. I'll just pause right here and I'll go into the question and answer session and see if anybody's got any questions. In the meantime, I've displayed the contact information of ourselves. If you've got anything, guys, let us know.
So, yeah, we've had a couple of questions come through, Karan. Mm-hmm. One is, does extra hop replace a SIEM or integrate with one?
Oh, absolutely. Very good question. So it depends. Generally, we're called the NDR player. NDR is one of the ways that you can get the telemetry, obviously, from the network. So we can complement the SIEM. Obviously, we can give out information to the SIEM, to the Splunks, to the IBM QRadars, to ArcSites, to logarithms and everybody. But if you don't have a SIEM, maybe you can start off with NDR, because NDR, as you've seen, is very, very comprehensive. So we can absolutely work with these guys. We've got out-of-the-box integrations with Splunk and logarithms and all of these players. And we can write the integration for your specific SIEM or for your specific tool. But if you don't have a SIEM, then you can obviously consider NDR as a starting point.
Okay, thanks. Yeah, another question is, you mentioned that there are no agents needed to be deployed on servers. Is there a central agent that is deployed to collect from the traffic mirror?
No, there's no agent in the traffic mirror at all. So that's like, think about a switch that you've got, or think about the VMware vSwitch. That vSwitch, you can do something which is called promiscuous mode monitoring. So basically all of the packets are sent to an extra hop collector. So replicated packets. So because of the packets, we can see everything. Think about, for example, a physical switch. That physical switch is receiving all the bearer traffic. Yeah. They just give us a copy of that traffic in real time. That is the same thing which is available in the cloud native environment. This is what it is. This is the traffic coming into a VPC. There's an EC2 instance. Then we can instantiate cloud natively within AWS a VPC traffic mirror session, which can stay there 24/7. And that's going to replicate the traffic via that VPC traffic mirror into ExtraHop. So no agents at all. This is just a switch configuration.
Okay. So, and the last question that was sent to me, is it possible to deploy ExtraHop Reveal from the AWS or Azure Marketplace?
Absolutely.
And is the license dependent on volume or subscription?
Absolutely. Very good question. So yes, it is doable. So what you can do is you can go to ExtraHop AWS Marketplace right here. And what you can see from there is there are 3 different form factors which are available to you. So there's an ExtraHop license. So obviously we're purely SaaS, and we're hybrid as well, both in AWS as well as the other marketplaces. So what you can do is you can get a sensor. The sensor is a 1 gigabit per second sensor. This could also be a 10 gigabit sensor, depending on the traffic that you've got. And this could also be a 25 gigabit per second sensor. Now you could also, obviously the cloud native tools like CloudFormation, we could orchestrate the deployment of these sensors with your specific policies. We could do that as well. And you can consume this as a pure SaaS-based service natively from AWS. This obviously, the SaaS service, pure cloud native, is available to AWS only. To Azure as well as GCP, the VMs are available. So, the likes of AMI equivalent in GCP and Azure, which are the VMs, you can just get the VMs in there. The pure SaaS-based service is available to AWS customers, but there's RevealX 360 hybrid service, which is depicted right here. This one. So in this one, the sensor could be anywhere, branch, native in the cloud, multi-cloud providers and everywhere. These components can also be in the cloud, which we manage for you. And if you're purely a customer who's got everything on-prem, you could have that available as well to you.
So just a question from my side. So is that sensor like an EC2 instance that gets deployed? And is the bandwidth kind of dependent on the bandwidth of the sensor?
Very good question. So think about AWS. AWS, the sensor that we go ahead and deploy, this is a 1 gigabit sensor. So what does that mean? That basically means it's an AMI. So that AMI obviously gets rolled out as an EC2 instance, right? But now it's a monitor product. So it needs to ingest the traffic. So wherever you're across the VPCs, within the same VPCs, wherever your ENI instances are, you can, via VPC traffic mirroring, you can send those ENI's traffic across to that ExtraHop EC2 instance in your monitoring VPC, as an example. And you would pipe that traffic from anywhere, the VPC traffic mirror sessions across under your account, right? So AWS accounts, if you've got, or even across multiple accounts, you could send the relevant traffic via VPC traffic mirrors into a security subscription where ExtraHop AMI is deployed. So you could do that.
Okay, great, thanks. I can't see any more questions in the little panel there. We have recorded this session and we will be making available on both Cloud 10 and ExtraHop websites. If there are no questions, looks like there's not. I'd like to thank everyone once again for their attendance, and I'd especially like to thank Karam for his excellent and very insightful presentation there. That about wraps it up for today. So thank you all for attending.
Thanks a lot, Richard. Cloud 10. Pleasure.
Thank you. Bye.